The topic we'll be discussing in this lecture is destination sequence distance vector routing algorithm. So DSDV, destination sequence distance vector routing, is an enhancement to distance vector routing for ad hoc networks. Distance network routings, distance vector routing is used with wired network. Okay, so this is an improved version of distance vector routing, which is called as destination sequence distance vector routing, which is used with ad hoc networks. Okay, so this algorithm, this routing algorithm works based on demand requirement. It works based on demand requirement. Okay, distance vector routing is used as a RIP protocol in wired networks, routing information protocol in wired networks. It actually performs extremely poor with certain network changes due to count to infinity problem. So when some network parameters were changed, this distance vector routing algorithm, it will create a problem, and that problem is called as count to infinity problem. And here its each node exchange its neighbor table periodically. Each node will exchange its neighbor table periodically with its neighbors. Okay, so that everybody will know their neighbors. Changes at one node in the network propagate slowly through the network. Okay, when there is any changes, that doesn't mean that change will propagate fastly. It will propagate actually slowly. So there are some strategies to avoid this. There are some strategies to avoid this in fixed networks to ensure that the changes propagate fastly. These are Poisson reverse technique and split horizon technique. But such technique, it will not work with wireless ad hoc networks due to the rapid change of the topology or the dynamic nature of the wireless ad hoc networks. Okay, and also this might create loops or unreachable regions within the network. This may also create loops or unreachable regions within the network. So DSDV basically it adds two things to the existing distance vector routing algorithm. These are sequence numbers and damping. So they add two new things to the existing distance vector routing algorithm. These are sequence numbers and damping. So let us see what is that. So sequence number, it includes, that is, each routing advertisement comes with a sequence number. Each routing advertisement comes with a sequence number. Okay, within ad hoc networks, advertisement may propagate along many paths. In ad hoc networks, the advertisement may propagate in many paths. It's not in one path. It will take multiple paths. Okay, so these sequence numbers will help to apply the advertisement in correct order. So different apply, the same advertisement may follow different path. Okay, so the sequence number will help the receiver to apply the advertisement in the correct order. So this avoids the loop that are likely with the unchanged distance vector algorithm. Okay, if you apply distance vector algorithm straight away, it may create loops that can be avoided by using uh, by introducing loops in in the distance vector algorithm. That is the improved version of distance vector algorithm, which is DSDV, destination sequence distance vector algorithm. So we are introducing sequence number, so that the algorithm name is destination sequence distance vector routing algorithm. The second thing it adds is damping. Transient changes in topology that are of short duration should not destabilize the routing mechanism. Okay, if there is any short changes in the routing, that may not permanent changes, that should not destabilize the routing mechanism. So advertisement containing changes in the topology uh, are not disseminated further. If the change is a transient one, then the changes will not be disseminated. So basically, when there is a short, basically before disseminating any change in the routing information, the node waits. The node waits for some times, whether these changes are probably unstable or not. Okay, if the changes were true for a certain amount of time, after that only it will disseminate. Okay, every small change it won't disseminate. Whenever there is a change, the node will wait to ensure that is this is a stable change or not. Once it recognizes that it is a stable change, then it will disseminate the information. Okay. So the waiting time, it depends. It depends how much time it will wait. That may vary. Okay. Waiting time depends on the time between the first and the best announcement of a path to a certain destination. Okay. So it depends on the actually the different paths. It depends on the time between the first and the best announcement of a path to a certain destination. So this is a brief overview about DSDV, destination sequence distance vector routing algorithm. Fine. Let us stop here. Thank you.